Okay. Good afternoon, everybody. So I hope you are doing well in this cold weather. So in this semester or in this term, so far we are just learning about open channel flow, right? So far we know the definition of open channel flow and the classifications of open channel flow and how we can calculate the uniform flow, critical flow, and all other things, right? And at the end, we started learning about gradually varied flow, right? So we know at this time what is gradually varied flow and what are the flow profiles. There are two types of flow profiles, like drawdown curve, and there will be another one which is backwater effect, right? So today we'll see, based on the 5 types of channel slope, there will be 13 different types of what are surface profile. That's what it is our objective for today. So we know the equation of gradually varied flow. So we derive this equation from the energy equation. So this is the equation, we know that. And in the previous lecture, we also know how to determine whether the channel or profile is drawdown or it is backwater curve. So if the dy dx part, the value of dy and dx is positive, that means the curve will be drawdown curve. And if it is negative, no. If it is positive, then it will be backwater effect. And if it is negative, then it will be drawdown. So we just learned these 3 profiles for mild slope. But there are 13 channel slopes, 13 different types of flow profiles. So I have tabulated these things here. I didn't show this thing last lecture. So here you can see, if the slope is horizontal, there will be 2 types of flow profiles here, and it is a critical, mild, and adverse, and steep. So there will be total 13 different types of flow profiles, and for which case the profile is backwater or it is drawdown is there in this table. We can find it here. And this slide is showing here, see, for mild slope, the profiles are there. The M1 is backwater, the M2 it is drawdown, and M3 it is again backwater. If the slope is mild, and right, we have seen this in the last class. But what about the steep? When the slope is steep, see, there will be 3 types of profiles. First one is S1, it is also backwater, and the second one is S2, it is drawdown, and third one is also S2, it is also backwater. So this is how we can just remember what are the types and how each type is representing the profiles of channel in the water, right? So most of the cases there will be a combination of steep and the mild slope in the real world case. So today we will see how to draw these flow profiles if we just identify the slope of the channel. Based on the slope of the channel and by knowing the critical slope of the channel, we can identify whether the channel slope is mild or steep. And if it is mild, then we can select any one from these 3 types of profiles. And if it is steep, then we can choose this one. Right? So the next slide, see. So this is the scenario or situation where you can identify or find the flow profiles. So if the slope of the channel is mild, and if you just construct any dam, so what will be the flow profile just in front of dam? See, it is this M1 profile. It is the backwater curve. And if the slope is also mild, right? And if you have any free fall, so what will happen? Just before free falling the water, it is M2 profile. And if there is any hydraulic structure like sluice gate, regulator, this type of structure has gate. These are called gated structure, right? So we can just rise the gate. So for example here, if you just rise the gate a little bit, and if the zone is located in the zone number 3, so what will happen? If the slope is mild, so there will be supercritical flow. And if the flow is supercritical, then it will try to make another transition from supercritical to subcritical. So if the flow is in transition state from supercritical to subcritical, so there will be a term which is called hydraulic jump. You didn't know about this. So when the flow has higher energy or velocity, so it will reduce its energy, or it is called a dissipation of energy by hydraulic jump. So this will happen here if the slope is mild and if it is located in the zone number 3. So what will happen if the slope is identified as steep? So if you just construct any dam or any obstruction on the way of a flow, and if the slope is mild, steep for this case, it will be S1 curve. And see the S1 curve, it is also looking like backwater effect. The curve is backwater curve. And for S2 curve, we need a different transition. It should be steep, and then there will be a free fall, or the steeper slope. Then we'll have S2, it is also drawdown. And the situation is same for S3. It is like M3. If you have gated structure here, and it is located in the zone number 3, there will be no transition for this case. See, there is nothing like hydraulic jump that we have for the case of mild slope. But for the steep slope, it is just S3 curve. So if you just keep these profiles in your mind, then you can draw any type of profiles. See, in real world situation, there is nothing like that. The slope is like, it is mild for 10 kilometer or 20 or 100 kilometer. There will be a transition or combination of channel slopes. That's why the profile will be also different. There will be a variation of profiles. So you have to be able to identify the transition, and you have to be able to draw the transition and the profiles. So here, I'm trying to just demonstrate something here. So for this case, see, we have a mild slope here, and then another slope, it is steeper, mild, and then we have steep. 3 types of slopes are there. It is mild, it is steeper, it is steeper, mild, and then I have here steep. Steeper mild means it is also mild slope, but it is a little bit steeper than mild slope, but still it is mild. So what will happen? So by this time we know there will be 2 lines. The first one is for mild slope. The NDL means the normal depth line and the critical depth line. So for mild slope, the NDL means the normal depth line is located above the critical depth line, right? Here. This is a CDL, and this is NDL. See? So when the slope is steep, the NDL is below the CDL. Otherwise, for mild and milder, since it is also mild, the NDL is above the CDL. So if the water surface is located here, so what will happen at this transition? Right? See, since it is just flowing from a slope which is mild, then steeper mild, so it is like something like free fall. So it will be, which one? It will be the M2 profile, right? That means it is drawdown. So it is something like this thing. And then it will just flow this way. And what will happen here? Since it is mild, it is steep, and see NDL is here and CDL is there. That means it will be M2 here, and then it will follow the S2 profile. So here it is S2, here it is M2, and here it is also M2 profile. Right? So if you know the transition and the slope, then you can just draw this flow profile. Right? So if you just know the flow profile, it is not necessary to calculate other things. But after knowing this flow profile, you have to be able to also calculate the depth of water or any other parameter at different locations. So how can you do that? So you cannot just apply any single equation and you cannot find it because it is gradually varying, right? So what you have to do? You have to follow different types of numerical method, right? So we have different types of numerical method. So for calculating this type of flow profiles, you need the discharge, you need the slope of the channel, right? You need the roughness factor, you need other information like energy coefficient. If you have all this information, then you can use this type of method. For calculating this flow profile, you can apply integration, direct integration method, or you can also apply the direct step method, or you can also apply the standard step method. These are the numerical method, right? See, the example of numerical method is like Euler method, or you have modified Euler method, right? So applying this method, you can easily calculate the flow profiles mathematically. So what will happen? Say anyone just can tell me, in the real world case, if I just convey water from a reservoir to a channel, right? And the channel slope is mild. Mild means I have this CDL here, and I have NDL here. And if the depth of water is also located here, the downstream of the channel, and if the reservoir water level is here, so what will be the flow profile at this interaction? Right? Since it is mild and I have water level up to this location, so it will follow the M2 profile to cross this line. It will be M2 or M1, it will be M1 because it is backwater profile. This is how we can identify profile and we can compute by using this method. So for today's lecture, so far we have learned what are the classification of channel profiles and how can we draw this profile, right? Now by this time we are able to draw, and we can follow the different types of numerical method, and we can compute by using the standard steps or Euler method, right? So this is the end of my lecture. So if you have any question, you can ask. Feel free to ask any question.
No question?
No?
Okay.
Do you have any?
Why is it important to know all the different flow profiles?
Because the channel is changing its slope, and that's why the transition is there.
So why is it important? Like,
Yeah,
to know all the differences?
yeah.
Mhm.
So if I want to construct or if I want to convey water, see? So in real world engineering, we're just conveying water from a reservoir. We have lake, we have reservoir, we're just conveying, right? We are just constructing or designing a channel, and if the slope of the channel is steep, so what will happen? If it is steep, so for example, if it is steep, so the profile will be different. It will be not like this. So it will be the S2. It will be this profile. So see, it is different than other one. The previous one was here, and now it is there. That's why I have to know what is the type of the profile to calculate the depth and the effect on the channel and its associated environment and other things.
All right, thank you.
Okay, thank you very much.